Welcome to day 5 of Are You Ready for AP Calculus? I cannot believe we've already made it to our last lesson. If this is your first time seeing me, I've got days 1 through 4 on my channel. You can go ahead, check them out to ensure that you are ready for AP Calculus this year. Let's get right on with it. Our first topic today is trigonometric equations part 2. We covered part 1 last lesson. Let's go for it. Solve for the unknown on the interval 0 to 2 pi. We have the natural log of quantity 2 minus sine squared of theta is equal to 0. In order to get to our unknown, theta in this case, I will take e to the power of both sides. This is because e and the natural log are inverse operations. So we have 2 minus sine squared theta is equal to 1. Anything to the 0 power, any non-zero number to the 0 power is 1. Let's go ahead and isolate sine squared of theta. I'm going to make it positive by moving it to the right side of the equality. 2 minus 1 gives us 1, and now we have the square root of both sides, and we get plus or minus 1. So then I'm wondering, where does this sine function give us positive or negative 1 on the unit circle? Because we're given the interval 0 to 2 pi. Let's draw it out really quick. Here's a unit circle. Sine of theta is equal to 1 and negative 1 right here and right here. Because sine relates to the y coordinate. So that's at pi over 2 and 3 pi over 2. That's it. Let's try the next one. We'll add 1 to both sides, then divide by 3 to get tangent squared x is equal to 1/3. Pretty much light work here. We're going to take the square root of both sides. We get the square root of 1 over 3. Don't forget to consider both the positive and negative solutions. Now this can be rewritten as 1/2 over radical 3 over 2, plus or minus. Since we have tangent, tangent is the same thing as sine over cosine. So basically what we're looking for is on this unit circle, we're looking for where the y coordinate is 1/2 and the x coordinate is radical 3 over 2. Those occur here, 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 and here because we are not really paying attention to where, to the signs. All we care about is that distance because it could be this entire fraction could be either positive or negative. So we have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Beautiful. Those are our values for x here. Let's try this next one. If 2 times cosine of 3t minus 1 is equal to 0, then cosine of 3t minus 1 will be equal to 0. Well, let's think about this. If we have cosine is equal to 0, that occurs at pi over 2, 3 pi over 2, 5 pi over 2, and so on and so forth. Oops, I wrote over 6, even though I said over 2. 7 pi over 2, dot, dot, dot. Now let's add 1 to both sides, then divide by 3. Well, if we add 1 to pi over 2, that gives us 2 plus pi over 2, and then that all divided by 3. Well, that will give us 2 plus pi over 6. Now let's think about where this is between 0 and 2 pi. 2 plus pi is about 5/6. We're thinking about pi, or let's think about where we get 1. 1 we get at pi over 3. So you're telling me 2 plus pi over 6 is similar or close to pi over 3, a little bit less than. So it seems like we're going to have to go many more than just to 3 pi over 2. Like we could have stopped here if we thought, well, our interval is 0 to 2 pi. Let's just stop at 3 pi over 2. But we need to consider t can be between 0 and 2 pi. So we keep going. We have 2 plus pi over 6. Next, we'll have 3 pi plus 2. So 2 plus 3 pi over 6. Let's see what that is. Well, 3 pi over 6, or 3 pi, is 9 plus 2. So 11 over 6 is about 2, almost 2. And almost 2 is at 2 pi over 3. So it does look like we're going to have 1, 2, 3, and possibly 4 more here on out. So we'll have 2 plus 5 pi over 6, 2 plus 7 pi over 6, 2 plus 9 pi over 6, and 2 plus 11 pi over 6. And let's check this last one. 11 pi is 33, plus 2 is 35, and 35 divided by 6 is almost 6. If you look at 2 pi, that is a little bit greater than 6, so we know that after this one, we can stop. Boom, there are your 6 options or solutions to this equation. Pretty neat stuff here. Let's try one more. Solve for the unknown, and this is where verifying your trigonometric identities and things like that may come in handy. We want a common denominator, so we are going to multiply both the top and bottom of this first fraction by 1 plus sine x. That'll give us 1 plus sine x squared for our very first fraction. And for the second fraction, I'll be multiplying by cosine of x on top and bottom. So I get cosine squared x. Now, all of this will be over cosine of x times 1 plus sine x. Again, we were looking for a common denominator. We've found it. Let's go ahead and distribute completely this squared. We'll have 1 plus 2 sine x plus sine squared x plus cosine squared x all over cosine of x times a 1 plus sine x. I don't know if you see it yet. It's kind of hard to see, but we do recognize positive sine squared of x plus a cosine squared of x is our OG, our original Pythagorean identity, and that will be equal to 1. That's where our unit circle equation comes from. So now we have a new equation. We have 2 plus 2 sine x all over cosine of x times 1 plus sine x, and something beautiful is about to happen here. This top portion, this numerator, has a common factor of 2. So if we factor out a 2, we get 1 plus sine x. Isn't this quite the beauty? We go ahead and we multiply both sides by cosine of x. Then we get 2 is equal to 4 cosine of x. Divide both sides by 4. So we're looking for where does the x coordinate on the unit circle give us 1/2. That's at pi over 3, 2, and only 2 versions because we're not dealing with both the positive and negative here. Only pi over 3 and 5 pi over 3. Wow, beautiful problem. Let's keep it moving. Topic 2, we are going to start looking at limits. I wanted to give you a little preview of what limits will look like, both algebraically and graphically, before you head into AP Calculus, because that's what I do in my pre-calculus courses. The graph of f of x is shown. Label each statement as true or false. The limit of f of x as x approaches a. What in the world does that mean? That means as x approaches a from either side, the value that my y value, the value that my function is approaching, so the y value is the same. As we approach a from either side, my function is approaching a y value of 2. Notice how we don't care about this closed circle here. We don't because it's not attached to the function. We are not approaching that closed circle in any way on the function when we're getting closer and closer to a. It does not matter what the function value is at that x value. The limit only cares about the approach. So this is saying 2 is equal to, well, let's take a look at b. As x gets closer and closer to b from either side, what is our function approaching? Oh, from the left and from the right, we are not approaching the same value. So the limit of f of x as x approaches b actually does not exist. So this first statement is false. We know this is true. We just solved it. This is false because we just solved that it does not exist. This is true. Now, f of b is equal to 1. Let's think about that for a second. If we plug in b into the function, what is the y value that we get? This is our x value. Plug it into the function. What do we get? The closed circle. And what is the y value at that closed circle? 1. So this is true. How about f of a? When we plug in a into the function, we get this closed circle. What's the value of f of 1? It's 1. So this is false because f of a is equal to 1. Let's try a couple more. The graph of f of x is shown. Circle the true statements. The limit of f of x. Oh, now we're dealing with some new notation here. As x approaches 2. And what do you think this negative means? When you have a negative, what do you think of? The left side of an axis. That's correct. We are approaching 2 from the left side. If we have x is approaching 2 from the positive direction, then we're approaching 2 from the right side. So as x approaches 2 from the left, what value is my function approaching? 2. It exists. True. As x approaches 2 from the right side, what value is my function approaching? 1. Yes, this exists. But are they approaching the same y value as x approaches 2 from either side? Because this one says x is approaching 2 from either side because their positive or negative does not exist here. Therefore, this one is false because we are not approaching, the function is not approaching the same y value as x approaches 2 from both the left and right hand side. One more. If the limit of g of x, let's write this down. If the limit of g of x as x approaches 3 is equal to 7, which of the following must be true? Well, the limit, again, only tells us about the approach, what the function is approaching. It does not tell us information about what the function value actually is at x equals 3. We do not know what this is based off of what we're given. So B doesn't necessarily have to be true. This, we don't know anything about x equals 7 here, y'all. Just no clue. However, if we know that the limit of g of x as x approaches 3 from either side is equal to 7, then both of these must be true. Whether we approach x from the left or the right, both of these must be true. Boom. C is your answer. Now, why is A wrong? G is continuous. Well, let's take a look back at this one, at A. Is f of x continuous at x equals A? No, because we have a removable discontinuity. There's a hole in the graph. Even though there's a circle here, we have to take our pen off the graph, plug in this, fill in this closed circle, and then keep going. Same idea. Just because the limit exists doesn't mean the function value exists. Therefore, G is not necessarily continuous at x equals 3. Algebraic limits. Solve the following limit expressions. Let's take a look at these. We have the limit of 8 minus 3x plus 12x squared as x approaches negative 2. Simply plug in those x values. So we have 8 minus 3, plug in negative 2 for x, and plug in negative 2 for x again. We have 8 plus 6. 4 times 12 is 48. So that gives us 62. Same idea. But what happens here when we plug in 5? 5 squared is 25, minus 25 is 0. 5 squared is 25, plus 10 is 35, minus 15. So we have 35 minus 15, that's 20. And that's just 0. Great. Beautiful. No worries here at all. Let's try this next one. When we plug in a 0, we get 0 on the bottom. And if h is 0, 6 squared minus 36 also gives us 0. 0 over 0 is what we call indeterminate. And let me tell you this right now. You're going to hear this from your AP Calculus teacher, maybe me. Indeterminate means is never a final answer. You can never stop at something being indeterminate. There is always something you can do if you get indeterminate as a result of your limit expression. What can we do? Well, we can distribute completely. We can get 6 squared is 36. 6h plus 6h is 12h plus h squared minus 36 all over h. Let's see what we get. And we have not solved the limit yet. We have not done the limit yet. So we need that limit expression there each time until we've actually used it. 36 minus 36, that's 0. 12h plus h squared. Has an h in common. These have an h in common. So we have 12 plus h all over h. Guess what happens? The h's cancel. Now plug in a 0 for h. What's 12 plus 0? 12 is our final answer. So we just went from having 0 over 0, which is indeterminate, to 12, which is an actual answer. Let's check this last one out. Tangent of 0 plus theta. That'll be, or not theta, but pi. And then 3 plus 0 is just 3. What is the tangent at pi over 3? Back to your unit circle. The sine value at pi over 3, or the y coordinate, is radical 3 over 2. The x coordinate is 1/2. The halves cancel. We're just left with radical 3. Make sure to subscribe if you enjoyed this or learned something new, or if you enjoyed my series at all. If you found it useful, make sure to subscribe. I'm going to be coming out with a lot more AP Calculus AB content this year. Really excited for the plan that I have for you guys. And leave a like on this video if you think it deserved it. Comment down below if you have any preferences on what you would like to see from me for AP Calculus AB, whether it be practice problems, actual lessons, or even AP exam type problems based on each topic. I'm so excited to bring you more. Make sure to check out the other videos on my channel as well, days 1 through 4 of this series. I hope you enjoyed, and I'll see you next time.